In the figure, ABC and AMP are two right triangles, right angled at B and M respectively. Prove that triangle ABC is similar to triangle AMP. So this is triangle ABC, which is right angled at B. So this is the right angle here. And here is a triangle AMP, which is right angled at M. We need to show these two triangles are similar. We already have one pair of angles that are equal, that is angle M equal to angle B equal to 90. So in ABC, the angle CBA equal to angle AMP equal to 90. This is given. So one angle. Let us see which is a common angle. If you look very carefully, you find this angle is common to both the triangles. So we have angle A equal to angle A because it is common. So we got two angles already equal. We got B equal to M, and now we have A equal to A. So the third angle C, this angle C must be equal to angle P. Let's mark that. So we have angle C must be equal to angle P by angle sum property. So we write angle C equal to angle P by angle sum property. So the three angles of one equal to three angles of the other, the triangles are similar. So triangle ABC is similar to triangle AMP by AAA test. Now if the triangles are similar, the corresponding sides are proportional, which means AB over AM will be equal to BC over MP. So we have BC over MP, which is also equal now to AC over AP. It is in the second part, it is given to us to prove that CA over PA equal to BC over MP. So we have CA. Here is our CA. So we've got to take this one, and we require BC. So these two we require. We do not require this ratio. So we can say now BC over MP equal to CA over PA. We've proved it. CD and GH are respectively the bisectors of angle ACB and EGF, such that D and H lie on the sides AB and FE of triangle ABC and triangle EFG. If triangle ABC is similar to FEG, show that CD over GH equal to AC over FG. So here's triangle ABC, and then we have triangle FEG, and it's given to us that these triangles are similar. So when they say triangles are similar, the angles, corresponding angles must be equal. Then it is given to us CD is the bisector of ACB and GH is the bisector of EGF. Let's mark that. So here is the bisector, this is bisector here, which means angle 1 must be equal to angle 2, and here GH is a bisector, so angle 3 equal to angle 4. If you look up in these two figures, there are so many triangles. The next question comes, which two triangles do we consider similar? For that, the answer comes from the result that they're asking you. They're asking you for CD. So mark CD. Here is CD. Then they're asking you for over GH. So this is now GH. Then AC. This is AC. And FG. So these are the sides that they're asking to be proved proportional. So from there you definitely agree that the triangle to be considered similar will be ADC because it contains both the sides. I put them in gray dots. And the other triangle to prove similar would be FHG. So we got to focus on these two triangles. So we take in triangle ADC and triangle FHG. Now this in here, it's given to us that ABC is similar to EFG. Let's write that out. I have triangle ABC similar to triangle FEG. This is given, which means now that angle A equal to angle F. So angle A equal to angle F. I'm going to go ahead and mark it in my figure. So this is angle A and it's equal to angle F because the triangles are given similar. Now next I mark is angle C will be equal to angle G. So angle C equal to angle G. Let me mark that in the figure. So we have this entire angle C equal to angle G. If the full angle C is equal to angle G, their halves also will be equal. So I can say angle 2 will be equal to angle 4. Now look at the triangles we have marked. We find two angles are already equal. One is a blue one and one is a green one. If the two angles are equal, the third angle also must be equal. Hence the triangles are similar. So we go ahead and write this. So we have angle A is equal to angle F, and the reason was because triangle ABC was similar to triangle FEG. Then we have that entire angle C. So next C equal to G. If C equal to G, half of angle C equal to half of angle G. And the reason for this is CD and GH are bisectors of angle C and angle G respectively. So two angles are done. So the third angle will automatically be equal by angle sum property. So I can write angle, this angle here, D, will be equal to angle H. So angle ADC will be equal to angle FHG by angle sum property. So the two triangles are now similar. So let me write the similarity correctly. So we know the two triangles are similar. So first we'll mark the blue. The blue were A and F. So A, F. Then we mark the green. So the green in the first case was C, in the second case for G, and then we mark the red. And that is D in this case, and H in the other case. So we just rewrite this. It's very important you write the correspondence correctly. So triangle ACD is similar to triangle FGH by AAA test. Now to write the similarity, to write the corresponding sides. So we have AC over FG will be equal to CD over GH will be equal to AD over FH. Now here, if you compare, we require CD and we require AC. So here is CD. In this ratio we got CD, in this ratio we got AC and CD. So this last ratio we ignore. So let me write it again. So we have now AC over FG equal to CD over GH, and we have proved this. So it's important to write all the three ratios and then decide which one is asked. Here's the same information given about bisectors and the angles that are similar. Here angles are similar, and here we're given CD, GH are bisectors. Now we need to prove that triangle DCB, so triangle DCB will be D, here DCB. We need to prove this triangle. We just join it up. DCB is similar to triangle HGE. So we have HGE. So this triangle. We already know the bigger triangles are similar. So this ACB was similar. Let's write that. Triangle ABC similar to triangle FEG, and this was given to us. So I can say angle A equal to angle F, which in this case actually I don't need. What I need in this case is that B equal to E. So angle B equal to angle E, and I'm going to mark that angle B equal to angle E. So here is angle B is equal to angle E because the larger triangles are similar. And then we had angle C equal to angle G. So angle C equal to angle G. So this entire angle C equal to angle G. If the entire angles are equal, the halves also are equal. So 1 equal to 3. If you consider these two triangles, if you consider this triangle and here this triangle, you will find that two angles are already equal. That is, B equal to E, the blue are equal and the green are equal. Therefore, the triangles must be similar. So in triangle DCB and triangle HGE, first we write B is equal to angle E, and the reason is triangle ABC is similar to triangle FEG. Then we have angle C equal to angle G. Same reason. Corresponding sides of similar triangles are proportional. So if angle C equal to angle G, half of angle C will be half of angle G. And if you look up in the figure, what is half of angle C? Is angle 1. Half of angle G is angle 3. Reason for this, CD and GH are bisectors, angle bisectors of angle ACB and angle EGF respectively. Now we got two angles equal, so the third angle will automatically be equal. That is, angle D will be equal to angle H. So we write angle D equal to angle H by angle sum property. So the triangles are now similar. To write the similarity, we have these two triangles similar. First we'll mark the blue. The blue was in one was B and the other one was E. then we mark the green, we have C, and we have G, and then we mark the red, which is D equal to H. So triangle BCD similar to triangle EGH. We could write it another way, like they have given, that is DCB is similar to triangle HGE by AAA test. But what is important when you write is the order should be kept correct. Look here, the D has to be equal to H, and that's in the figure. And then we have the blue one, that is B, should be equal to E, and C will be equal to G. The order remains the same. For the next part, the earlier information is the same. Now here we've got to show that DCA. So this is DCA, which means it is triangle DCA is similar to HGF, and this is HGF. So here we have HGF. Oh, this was not right. DCA is on the top. These were both wrong. So we have DCA is here. DCA is this triangle, and HFG is this triangle. And we have already proved that these are similar because the bigger triangles were similar. So A was equal to F. Then we said the entire C is equal to entire G, which means half of it also be equal. Two angles are equal, therefore the third angle also will be equal. So in these two triangles, first I'll say angle A equal to angle F. Reason triangle ABC is similar to triangle FEG. So these are the corresponding angles of similar triangles. Then next we have angle C equal to angle G. Here also same reason, ABC similar to triangle FEG. If C equal to G, so half of angle C is half of angle G. Half of angle C is angle 2, half of G is angle 3. And the reason for this is CD and GH are bisectors of angle ACB and angle EGF. So two angles are equal, so the third angle also will be equal, and the third angle is D equal to H. So we'll say now triangle, we write that D equal to H, angle D equal to angle H by angle sum property. So you have triangle DCA similar to triangle HGF by AAA test. Here I made a mistake, and this should be corresponding angles of similar triangles are equal. In the figure 6.40, E is a point on the side CB produced of an isosceles triangle ABC, where AB is equal to AC. We'll need this information later. AD is perpendicular to BC and CF is perpendicular to AC. Prove that triangle ABD and ECF are similar. So we have now first triangle is ABD. So ABD is ABD. So we join that up. We need to show ABD is similar to triangle ECF. So that is ECF, and here we have ECF, this triangle. We need to show both these triangles are similar. So it is given to us AB is equal to AC. Now if AB is equal to AC, the two angles also will be equal. So we have here AB equal to AC. So we have angle B is equal to angle C. So let's start with that. We have AB equal to AC, and this is given. So we have angle ABD equal to angle ACD, angles opposite equal sides. So we got one angle. We have this angle here equal to this angle here. And if you notice that there is a 90 degrees. This is 190 in one angle and this 90 is in the other angle. So we have angle ADB is equal to angle EFC, and the reason is this: AD perpendicular to BC, EF perpendicular to AC. So we write that the reason AD perpendicular to BC and EF perpendicular to AC. So here two angles of one are equal to the two angles of the other, so the triangles must be similar. So we have first taken this triangle, which is ABD, and then we have this triangle, that is ACF. And we very closely look at both the triangles. Two angles are equal. One of the blue angle is equal and the orange angle. So the triangles must be similar. Now we're writing the similarity. So we have triangle. Before we write the similarity, let's mark the third. For the yellow one, this is the third angle, and for the blue one, E is a third angle. So now let's write the similarity. First, the blues were equal. The blue in here B equal to the blue here in C. Then next we write the right angles. So the D, and here the right angle is at F. Let me just make it easier for you. Here we are writing this angle, the yellowish one, and here we are writing the greenish one. Then last we have in the yellowish one we have E. A will be equal to here E. We arrange it again. So if we write now, see what they have given. They have given show ABD equal to ECF. So if we write A here, we need to write E here because A corresponds to E. Then if we write B here, we need to write C here. And now if we write D here, we need to write F here. So the triangles are similar by A test. The third one we need to write here, and that is angle A is equal to angle E by angle sum property. A vertical pole of length 6 meters. So here's a vertical pole AB of 6 meters. Cast a shadow of 4 meters on the ground. So here is a shadow of 4 meters on the ground. So when I write, I have to say let AB represents the pole, which is equal to 6 meter, and AC represents the shadow of the pole, which is 4 meter. And at the same time, a tower casts a shadow of 28 meter long. So here we have DF, which is the shadow. So DF is the shadow of the tower, which is equal to 28 meter, and ED is that represents the tower, which is 8x meter. We need to find x. We need to find the height of the tower. So you definitely agree you got to consider triangle BAC and triangle EDF and prove that they are similar. One is 90 degrees, angle A equal to angle D, which is 90. So let's mark that. Angle A equal to angle D, which is 90. And now this angle is called the angle of elevation of the sun. You know, we have the sun somewhere here, that's why we get the shadow, and this is called the angle of elevation of the sun. Same thing in this case here, the sun would be somewhere here, and this angle line joining the line of sight from the point to this sun is called the angle of elevation of the sun. And at a given point, the angle of elevation of the sun is equal. So this is angle of elevation, and here in this figure, this is angle of elevation. And in a given place, the angle of elevation is always equal. So now we'll write angle C equal to angle F, the angle of elevation at a place, angle of elevation of sun at a place is considered equal. So in these two angles are equal. The third angle will also be equal. We'll mark the third angle here. B will be equal to E. So you'll agree that the two triangles now are similar. So we write angle B equal to angle E, angle sum property. So now we take triangle. Both the triangles are similar. Let's write the similarity. We showed A was equal to D because both were 90. Then we had C equal to F, angle of elevation, and we have B equal to E. So the triangles were similar by A test. So you have triangle ACB similar to triangle DFE. So we'll have AC over DF equal to CB over FE equal to AB over DE. Let's put the values that we know. We know AB as 6, so AB is 6 here. AC as 4, so AC was 4. Then on the other side we know ED as X, and ED or D is X, and FD is 28. FD is 28. Now we have no values of this, so we ignore it. So we go on again. So 4 over 28 equal to 6 over X. So 1 over 7 equal to 6 over X. And we got X equal to 6 into 7, which is 42 meter. So the height of the tower, which was taken as X, is equal to 42 meter. AD and BM are medians of the triangle ABC and PQR respectively, where triangle ABC is similar to PQR. Prove that AB over PQ equal to AD over PM. So first we are given triangle ABC is similar to triangle PQR. That's one thing. This is one thing that is given to us. And the second thing, that AD and PM are medians. So AD and PM are medians of triangle ABC and triangle PQR. Now we need to prove, this is what we need to prove. So prove AB over PQ is equal to AD over PM. In this sum, we are going to take triangle ABD and triangle PQM and prove that they are similar. So ABD and triangle PQM. It was given to us earlier that these large triangles were similar. ABC was similar to PQR. If ABC is similar to PQR, we can say that B is equal to Q. Let me write that somewhere here. So I have, if triangle ABC is similar to triangle PQR, I can write angle B equal to angle Q. And let me mark this, so I know angle B equal to angle Q because the larger triangles are similar. So I write first point, angle B equal to angle Q. The reason, triangle ABC is similar to triangle PQR, and hence I get B equal to Q. Now if AB is similar to PQR, the corresponding sides also are proportional. So back again, I will say if ABC is similar to PQR, so I can write AB over PQ will be equal to BC over QR. So AB over PQ. Now if you look at BC, I can write for BC half, for BC I can write twice BD. Why can I do that? Because if you look up here, this is the median, AD is a median, so D is a midpoint. So definitely you will agree that BD is half of BC. Similarly in this case, PM is a median, so M is a midpoint. So and you will agree that QM is half of QR. So this is over. For QR, I can write twice QM. And the reason for this is AD and PM are medians. So when I cancel, I get AB over PQ is equal to BD over QM. Let's go over that again. It was given to us that triangle ABC is similar to triangle PQR, which means we first use this information. We said B was equal to Q. So angle B equal to angle Q because the triangles were similar. And we also use the other information that AB over PQ was equal to BC over QR. So we can write AB over PQ. For BC, I can write half BC, multiply half in the numerator and the denominator. The fraction does not change. So AB over PQ equal to, what is half of BC? Look up in the figure and see. Half of BC is BD, this. And half of QR is QM. So here I can write half of BC, I can write as BD. And here I can write QM. So I got now BD over QM equal to AB over PQ, and these two angles are equal. So I can say by SAS test the triangles are similar. So if I take up triangle ABT, and let me mark this properly, this is A, B, C and D, this is P, Q, M and R. Triangle ABD will be similar to triangle PQM, and the reason B equal to Q, AB over PQ equal to BD over QM. So triangle ABD similar to triangle PQM by SAS test. And if that's the case, I can say AB over PQ equal to BD over QM equal to AD over PM. And they want to show AB over PQ, so they need this ratio, AB over PQ and AD over PM. AD over PM, they require this ratio. We don't require this ratio. So we ignore this ratio and we write AB over PQ equal to AD over PM. The reason in similar triangles, the corresponding sides are proportional. The corresponding sides are proportional.